Hello everyone. In this lecture, we are going to see about color image histogram operations. For that, first two lines will be same as we have done in all the programs for clearing of console, reading the image using IMRead function, IMRead of lion.jpg, semicolon. And in the next step, now I am going to create the subplots. Figure subplot of give some random size. Let me take with a size of 2 rows, 3 columns at position 1. Uh, and now I am going to use one thing is title and one more is for displaying image. I am show function original image. As I have mentioned histogram for in case of all subplots, don't blindly or blunderly use of I am show. You must and should use the plot 2D tree function to display histogram. Here I am displaying image, so I have used it as A. As you know that in while discussing the noises, there I have also mentioned not noises while discussing the different color image models. There we have obtained the RGB values, right? Same here also we are going to get those RGB values, R value, G value, and finally B value. Yeah. And now also grayscale also we are calculating. We are not directly converting it to grayscale because the reason is you already aware of making use of grayscale in displaying histogram in the starting lectures. So now I am using how do you calculate actually without the pre-built function R plus G plus B by 3. This is the functionality that every pixel makes use. And while discussing the histogram display, we have considered two parameters count comma cells and then we have used IMHist function and in this we have given the grayscale image. While discussing only with grayscale, but here I am performing color image histogram operations. So let me take some count underscore R for R with respect to color, you keep underscore with that respect to color. Any name you can give, but don't give similar names in this case. Since it is belongs to R, I am using R here. Let me copy this line because 4 times you are going to enter. And here for green color, we are going to do R, G. Then for blue color. And also for gray value also we are going to do that is nothing but I value RGB. Yeah. Now for I value also we are going to do grayscale. This will be gray level plotting. For verification, you can also use the previous one where we have directly converted to gray and then histogram. Here only pixel value we are making use. And now for the purpose of display subplots we are going to use. Four plottings are required. One is already in use. Now two. This is belongs to not image red portion histogram or I'll tell it as Z histogram. Don't use the word image here because it is plotting again and again. I am saying don't use I am show function in these cases. Use the plot function plot 2D tree. This is a function used to print for histogram and here the first parameter is GNN followed by cells we are going to give cells underscore r comma count underscore r for red portion. Now copy the same at position 3. Now I am going to use it as green histogram. For green use cells underscore g and here use count underscore g. And next, for blue portion, position 4, blue histogram, cells underscore B, comma, count underscore B. Next, the last one is for gray level, position 5. Let me name it as gray histogram, cells underscore I, count underscore I. Now I am saving this. I am naming it as colorist, colorist. Already the file exists. Replace. Now execute it. Yeah, you can see 5 plottings you have obtained original image. As all these are plottings, use plot 2D3 function. And you can see this is for red portion, this is for green portion, this is for blue portion, and this is the gray histogram. For this, you can also make use of previous lectures to obtain. But for RGB, this is the process. This count cells and this plot 2D3 function are mandatory for obtaining an histogram. This is how we work with color image histogram operations. And in the next lecture, we are going to discuss about various different kinds of image morphology techniques and image rotations. And this is how the color image histogram operations we can perform. Thank you.